We're doing section 7.1, example 6. So this is a word problem. Basically what we're told is we have the acceleration due to gravity in feet per second squared. And that we're asked to find the a couple of things about a ball thrown off of a particular skyscraper. So the information we're given, this is really what we have, and then we have the height of the building that we're throwing this off of, and we also have the initial velocity. So what we're going to do is we're sort of going to work backwards. We know the acceleration, and if we remember, if we start off at the position function, we call that s of t. If we take one derivative, we get down to velocity. If we take another derivative, we get down to acceleration. So in other words, if I want to go backwards on this, and I want to go one step up on this to find velocity, what I need to do is find the antiderivative of the acceleration function. So you can kind of think of this as like a hierarchy of functions. At the top is position, below that is velocity, below that is acceleration. If you want to go from the top to the bottom, you take derivatives. If you want to go from the bottom to the top, in other words, start at acceleration and go up, you do antiderivatives. Okay, so what we first want to do here is find the antiderivative of minus 32. Okay, that's a constant, so its antiderivative will just be minus 32 times the variable of integration, in this case t, plus some constant. Okay, now this is where the initial conditions are coming in, which I didn't write, but it says that the object has an initial velocity of minus 20 feet per second. So what that's saying is that v of 0 is equal to minus 20. Now what does that mean? That basically just means that whoever was standing on top of this building threw this thing downward with that velocity of minus 20 feet per second. Okay, so we can use that information to figure out what that c has to be in the velocity function. So what we know is that v of 0 is minus 20. In other words, if I plug in 0 to that function, I will get minus 20 out. So basically, if t is 0, then v is minus 20. And this is what allows me to find c, because 0 times this is 0, so that's going to tell me that c is equal to minus 20. So I've found the constant from the initial condition, so my velocity function in total now, everything included, is minus 32t minus 20. Okay? Now the next step is to realize that if I want to find the position function for this thing, so I'm going to go one more step up to the top of this function hierarchy. At the bottom is acceleration, at the top is position. Now that's going to be the antiderivative of the velocity function. Okay? So we're working our way up to the top here. So I want to find the antiderivative of the velocity function, which we just found. So really what we're doing is kind of two different integrals here. Okay, so the antiderivative here, we use the power rule. I'm going to raise that by 1. The power is 1. It's now going to become 2. And I'm also going to divide by that power. So I'm going to get minus 16 t squared. Now here I'm going to have minus 20. If it's the antiderivative of a constant is just that constant times t. Then I'm going to have another constant here associated with the position function. And I had another initial condition here. That is the initial position. Since this person was standing at the top of this building that was 2,717 feet tall, what I know is that my initial position must be 2,717 feet above the ground. So just like we saw last time, to figure out what this c is, I know that when t was 0, the initial height was 2,717. So again, if I plug zeros into here and have this set equal to 2717, that's going to tell me that that c is going to be equal to 2717. So s of t is actually minus 16 t squared minus 20t plus 2717. Okay, now the question is actually asking us to find the velocity of the object when it hits the ground, and how long does it take to hit the ground. So to answer these questions, how long does it take to hit the ground? Well, that question is really how long does it take to reach position 0? So the ground, according to what we're talking about here, is position 0. So to answer that question, I want to set this equal to 0 and then solve for t. Okay, now I'm not sure if this is going to factor. In fact, I'm pretty sure it won't, but let's just go ahead and try that. I'm going to just do this on my calculator. And again, if you're doing this on my math lab, you can certainly find something online that's going to solve such an equation like this for you. You can, of course, use the quadratic formula to figure out what the solution with this set equal to 0 would actually be. And that will certainly work, but I'm totally fine if you want to use some online program to do that. Okay, so it turns out this does not factor, of course, so what do we want to do? We will definitely have to use the quadratic formula for this. So I'm going to just set this up in my calculator. And I get two values. One of them is negative. We can just disregard the negative value. If I set this to 0, I'm going to get on the calculator t is equal to a negative value. Again, we don't care about that because negative time doesn't make any sense here. 12.4 seconds. Okay. And again, there's plenty of websites where you can say, like, just type into Google quadratic equation solver. So, and then if you find the website, it'll just ask you to enter these numbers. It'll solve it for you. It'll give you that. Or, totally welcome, just use the quadratic formula on your own if you want to do that. Okay. So that answers the question about when this thing is going to hit the ground. Let's see. Just want to make sure I'm answering all the questions here. We found the function. We found when it hits the ground. And how fast is it going when it hits the ground? So to do that, we have to use the velocity function for that. How fast is it going when t is equal to 12.4 is really what we're after. So if I plug 12.4 into the velocity function, that's the velocity function there. Again, we're of course assuming no air resistance here, which is probably not that great of an assumption, but for the purposes of this problem, we'll have to make that assumption. If you do include air resistance, things of course become a lot more complicated. So if I put this in, 12.4 and minus 20, I get minus 416.8, and the units on that would be feet per second. And again, it's okay to have a negative velocity. All that indicates is that we're going in the downward direction, which would of course make sense. If you throw something downward from the top of a building, it's definitely going to be having a negative velocity if you consider downward to be the negative direction. Okay, and I believe that answers all of the questions on here. We found S of t, we found the velocity of the object when it hits the ground, and we found how long it takes to hit the ground. So we've answered every question on this problem.